What if I told you there's a theory so disturbing, so quietly feared, that many physicists avoid saying its name aloud? An idea suggesting that death, the absolute end you've been taught to expect, might never actually arrive for you. Picture every danger, every close call, splitting reality into paths, and your awareness sliding only into the one where you keep breathing. What if, without realizing it, you've never stopped surviving? You're about to step into a corner of physics where intuition collapses. Quantum theory says reality doesn't decide anything until an observer appears. Until you appear. Particles linger in multiple states, waiting for a witness. If observation shapes outcomes, then what shapes the final moment of your own existence? And what if consciousness never follows the branch where it disappears? Before we can even approach the idea of quantum immortality, we need to step into the strange heart of quantum mechanics, the place where the observer is not just a witness, but a participant. In classical physics, the world behaves whether you look at it or not. A stone falls, a star burns, a clock ticks, your presence changes nothing. But the quantum world refuses to play by those rules. It demands your attention, and more than that, it demands your involvement. At the smallest scales, particles do not commit to being here or there, spinning this way or that. They exist in ghostly combinations of possibilities, superpositions, until something forces them to choose. You've heard the cliché that observation collapses the wave function, but clichés often hide the discomfort beneath them. What does it mean for the universe to wait for someone to look? And who counts as someone? The famous Schrödinger scenario was never meant to be a puzzle about cats. It's a puzzle about you. Inside the sealed box, the cat is suspended between life and death because the quantum trigger that might kill it is also suspended. No single outcome exists until an observer opens the box. But why should your awareness determine whether a creature is alive or dead? Why should the cosmos behave as if consciousness is the final judge? This is where the discomfort begins. The line between physical reality and subjective experience starts to blur. If a particle is in a superposition until observed, then what happens when the observer is part of the system? You cannot step outside your own mind to measure it. You cannot open a box around your own consciousness. And suddenly the question becomes dangerously intimate. When you observe the cat, its fate becomes definite. But when the cat observes you, what collapses? What is the universe choosing for your state of being? The classical world feels solid because billions of interactions are constantly forcing choices, constantly pinning down specific realities. This is what physicists call decoherence, the drowning out of quantum strangeness by the noise of everyday existence. Everything is continually observed, measured, bumped into, entangled with. It's a world that feels stable because it has no room left for ambiguity. Yet even in this vast network of interactions, one thing remains unresolved. What role does the observer's experience actually play? When you watch a particle choose a path, reality seems to crystallize. But from the particle's viewpoint, if such a thing can be imagined, there is no single moment of decision. There are only branches, possibilities, and the unfolding of mathematical structure. This is the foundation on which the later, stranger ideas stand. Every outcome exists, but you only perceive one. You are the witness walking a single thread through a tapestry of many. And the more you think about it, the more unsettling it becomes. Because if reality waits for your perception before locking into place, what happens when the outcome in question is not the spin of an electron, but your own survival? The observer problem forces us to face a simple, terrifying idea. You never observe your own non-existence. Your awareness filters the world not just passively but actively. Every memory you carry is a record of the branch in which you continued to exist. Every moment of danger in your life ended in the version where you walked away. Your consciousness has never once encountered the branch where it stopped. This is not yet quantum immortality, but it is the ground on which it stands. The quantum world allows multiple outcomes to coexist. The classical world hides them, but your subjective world follows only one. And the act of following, of experiencing, of observing, may not be as neutral as you think. In this tension between possibility and perception, between the silent branching of worlds and the single line you inhabit, we take our first steps toward the forbidden idea that the observer might never witness their own end, because consciousness may forever slide into the branches where it still exists. To understand why quantum immortality emerged at all, we need to walk into one of the boldest, most controversial interpretations of quantum mechanics, the many worlds interpretation. It began with a young physicist named Hugh Everett, who refused to accept the idea that the universe collapses when someone looks at it. For Everett, collapse was an illusion, an unnecessary patch sewn onto the theory to make it feel comfortable for human intuition. He argued that the wave function never collapses. Instead, every possible outcome actually happens. The universe doesn't choose, it branches. Imagine a particle traveling toward a detector. In the textbook version, the moment you measure it, the superposition disappears and the particle decides which path it took. Everett insisted that the particle doesn't choose at all. Both results occur, each in a different, newly formed branch of the universe. What you call collapse is simply your consciousness sliding into one of those branches, blind to the others. This idea was radical because it changed the role of observation. In the traditional view, you are a gatekeeper who forces nature into a single form. In Everett's view, you are a traveler, carried along one path while countless others unfold without you. Every decision splits reality. Every random quantum event spins off versions of the world where things go differently. Your life becomes a thread, woven through a vast, shimmering fabric of alternatives you will never see. At first, this sounds like science fiction. But many leading physicists, David Deutsch, Sean Carroll, Max Tegmark, take the many worlds interpretation seriously because it removes the need for wave function collapse. It gives the equations exactly what they ask for: linear evolution, no interruptions, no special rules for observers. It is, in a sense, the simplest explanation. The universe just keeps going, splitting endlessly, without ever destroying information. Carroll often says that the branching is not something you would ever notice. You don't feel the universe splitting because you're part of the split. You don't sense the duplication because your consciousness follows only one copy, just as you don't feel the Earth hurtling around the Sun at 30 kilometers per second. The fundamental motion is there, but nothing in your experience reveals it. This is where the idea becomes uncomfortably personal. If every possibility continues, then there are worlds where you live and worlds where you die. Worlds where you miss the car crash by inches, and worlds where you don't. And because you never experience the branches in which you cease to exist, your subjective reality glides only through the ones where you remain alive. This is not yet the argument of quantum immortality, but it is the landscape that makes it imaginable. Consider a simple probabilistic event. You flip a quantum coin. Instead of heads or tails, Everett would say there is a version of you watching heads and another watching tails. Both are real, but each one feels like the only true outcome because consciousness is never aware of its counterparts. Multiply that by every heartbeat, every breath, every moment in your life that could have gone otherwise, and you begin to see the scale of the Everett universe. A single lifetime becomes an intricate map of diverging histories, only one of which you ever know. The many worlds interpretation reframes your existence not as a line but as a pattern. The you reading this sentence is only one of many, each following a slightly different path carved by quantum events far beneath your awareness. The fact that you perceive a continuous, stable world is simply a property of decoherence, the way branches become so distinct that they no longer interfere. You are locked into your branch the way a boat is locked into a particular current in a vast ocean. The other currents exist, but you never feel them. And this is where the disturbing thought arises. If consciousness never observes its own disappearance, and if every outcome where you survive also exists, then your subjective experience might be forever pulled toward the versions of reality in which you remain alive. Many worlds does not guarantee immortality, but it creates a structure where immortality becomes, at the very least, a logically consistent possibility. The grounding of quantum immortality is not a mystical belief. It is a consequence, perhaps an unintended one, of Everett's refusal to collapse the world. The universe branches, you follow one branch, and the branch you follow is always one in which you continue to exist. Whether this is fate, illusion, or misinterpretation remains uncertain, but the possibility itself is enough to unsettle the meaning of life, death, and identity. At the center of quantum immortality lies an idea so simple, so slippery, that it feels almost impossible to hold in your hands. Consciousness may only experience the branches of reality in which it continues to exist. This is not a claim about physics proving immortality. It is a psychological consequence of how subjective experience might move through the Everettian multiverse. To grasp it, you have to look at your own awareness not as a fixed object, but as a thread, thin, persistent, and always weaving itself toward survival. In the many worlds interpretation, every quantum event creates a branching of reality. Those branches do not annihilate each other, they unfold independently. But your consciousness does not divide with them in any way you're aware of. You never feel your experience split. You only ever feel like one continuous self moving forward. The question then becomes, along which branches does your conscious experience flow? Here is where the argument grows unsettling. You have never witnessed your own death. You have seen death happen to others, and you have imagined it happening to you. But you have never experienced the moment of not being alive. You cannot. Your awareness can only record the branches in which awareness persists. Every second of your life, every memory, every emotion, every breath has been recorded from within a continuous stream of existence. Now imagine the branching structure of reality as a vast, expanding tree. At every moment, countless branches diverge. Most of them are mundane. Some hold danger. A rare few lead to sudden endings. According to quantum mechanics, they all exist, but your conscious experience, bound by its own nature, is incapable of continuing down the branches in which it ends. In those branches, there is no observer left to observe. So the core of the quantum immortality argument is not that you never die in the physical sense. You certainly do in many branches. The argument is that you never experience those deaths. The line of consciousness continues only along the paths where it remains able to observe. It is like a river flowing downhill. While many channels may form, the water travels only through those that remain open. This is why the thought experiment of quantum Russian roulette became so famous, despite its absurdity and ethical discomfort. If a device linked to a quantum event has a 50% chance of firing and a 50% chance of staying silent, then in the Everett model, both outcomes occur. In some branches, the experimenter dies instantly. In others, the gun clicks harmlessly. And from the experimenter's own perspective, their conscious experience continues only in the branches where the click is heard. They never become aware of the branches in which they no longer exist. Of course, this does not mean they survive in any branch where the laws of biology forbid it. They may be severely damaged, injured, degraded. Consciousness can cling to continuity even in forms of life that are agonizing or diminished. The argument has nothing to do with invincibility. It is about subjective continuity. It is about the impossibility of perceiving your own non-perception. This line of thought pushes us into territory where physics, philosophy, and introspection collide. What is consciousness if not the experience of being aware? And if that experience must always occur from the viewpoint of someone who is still alive, then your personal timeline becomes filtered by that requirement. You may not be choosing the safe branches. You may simply be unable to witness the fatal ones. Critics argue that this is a misunderstanding of probability, that higher amplitude branches should dominate your experience. But the central idea persists because it appeals to something primal, the raw fact that your awareness has never once flickered into non-existence. Not in dreams, not in near accidents, not even in moments when you should have died, but didn't. The branch you remember is always the one where you survived. Whether this continuity is an illusion, a misinterpretation, or a genuine reflection of how consciousness navigates the quantum landscape remains unresolved. But the argument itself is powerful because it asks you to confront the one aspect of reality you cannot escape. The unbroken line of your own awareness, tracing itself through a universe full of paths you do not remember but may still inhabit. No idea within the quantum immortality debate is as disturbing or as clarifying as the thought experiment known as quantum Russian roulette. It was designed not as a stunt, but as a ruthless way to expose the logic hiding beneath the many worlds interpretation. Its premise is brutally simple. If every possible quantum outcome occurs in a branching universe, then there must be branches where the trigger fires and branches where it doesn't. And because consciousness can only continue in the branches where it survives, the experimenter would always experience survival, no matter how unlikely it becomes. Imagine a device connected to a quantum event, something genuinely unpredictable, like the decay of a radioactive atom. The device is calibrated so that if the atom decays within a given interval, a mechanism fires a shot. If it doesn't decay, there is only a harmless click. In classical terms, there is a 50% chance of death and a 50% chance of survival each time the experiment is run. From the viewpoint of an outside observer, the expected outcome is simple. Run the experiment enough times, and eventually the experimenter will die. Probability demands it. But Everett's worldview rejects the idea of a single outcome. In the multiverse, the experiment doesn't end with one event. It produces two entire branches of reality. In one, the gun fires and the experimenter dies instantly. In the other, it clicks and nothing happens. Both outcomes unfold in full, but the experimenter's consciousness persists only in the branch where they continue to be conscious. They never wake up in the branches where they are dead. They never register the sound of the gunshot. They never experience the darkness that follows. From their internal perspective, the experiment becomes a sequence of improbable victories. Click after click after click, a pattern so extraordinary it feels supernatural, a survival streak that statistically should be impossible. And yet, within the logic of quantum immortality, such a streak is not impossible at all. It is the only sequence of events the experimenter is capable of experiencing. All the other versions of them, countless, innumerable, ending in seconds, exist in other branches, forgotten by the only observer that matters to itself. This is the haunting core of the argument. From the first-person viewpoint, survival becomes mandatory, not physically, but experientially. The consciousness cannot continue in a branch where consciousness has ended. Therefore, the only version of the experimenter who can report back, the only one who continues having experiences, is the one who survives. And so the many worlds interpretation creates a terrifying asymmetry. The experimenter perceives immortality, while everyone else observes annihilation. But this immortality is not the whimsical kind that appears in myths or fantasies. It is closer to a curse than a gift. Keep running the experiment, and the branches where the experimenter survives become increasingly rare. Their body may bear the cost: injury, degradation, neurological trauma, because survival doesn't guarantee well-being. It only guarantees awareness. The more unlikely the survival branch becomes, the more broken the survivor may be. The thought experiment forces us to imagine a version of ourselves clinging to life in an ever-narrowing corridor of possibilities, surviving in ways that no sane person would ever want to experience. The significance of this scenario is not in encouraging the experiment, but in revealing how consciousness might traverse the multiverse. It exposes the tension between objective probability and subjective experience. An outside observer sees risk. The participant who continues to exist sees inevitability. The multiverse does not privilege survival, it simply contains it. But your experience privileges survival because non-survival cannot be experienced. Quantum Russian roulette became infamous because it cuts away all abstractions and leaves only the raw logic of the argument. It forces us to ask, if consciousness follows the branch where it remains alive, does it mean that every close call in your life pushed you into a version of reality where you walked away? Does every lucky escape hint at a deeper, unseen structure guiding the continuity of your awareness? Or is this entire notion a misinterpretation, a seductive illusion drawn from a theory that was never meant to touch the human mind so directly? The thought experiment does not resolve these questions. It only sharpens them. It shows that if many worlds is real and consciousness is tied to experience, then survival becomes the only story you are ever capable of telling. And the most frightening part is not the possibility of immortality, but the possibility that you have already lived through branches where you should have died, and simply do not remember the versions where you didn't. If quantum immortality were simply a path toward endless life, the idea would be strange but comforting. Yet its true weight, the part that keeps physicists and philosophers uneasy, lies in the kind of life it implies. This is not the immortality of myth or fantasy. It is not eternal youth, not invulnerability, not transcendence. It is survival at any cost. It is consciousness dragged forward through every branch in which it continues to exist, no matter how broken, improbable, or painful those branches become. Imagine the branching structure of the multiverse, not as a wide and open landscape, but as a narrowing corridor. Each moment presents countless possible futures, but the ones in which you remain alive may become fewer and fewer. You continue moving through that shrinking path, not because the universe protects you, but because consciousness cannot follow the branches where it has ceased to be conscious. The result is a version of immortality that feels less like a gift and more like a trap. Philosophers like David Lewis and Derek Parfit have pointed out the same disturbing implication. The only you who keeps experiencing reality is the version who hasn't died yet. But nothing says that this surviving version must be healthy, comfortable, or even happy. Your continuity could persist through injuries that should have been fatal, through diseases that statistically should have ended your life, through accidents where most branches of reality leave you dead. In each of those other worlds, countless copies of you perish instantly. But the version reading these words is, by definition, the one who didn't. This creates a strange and eerie asymmetry. To the people around you, your existence ends when your body fails. In the branches they inhabit, you are gone. But from your own perspective, every time you approach the edge of mortality, something improbable happens. A diagnosis comes late, but not too late. A car veers at the last moment. A blood clot dissolves just in time. A doctor's guess is off by a fraction, yet enough to push you into the narrow passage of survival. You feel lucky. They see fragility. Both perceptions are correct within their respective branches, but the darker side of this idea emerges when you imagine survival dragging on past the point where life still feels like life. What happens if the only branches in which you continue to exist are the ones where survival is technically possible, but deeply agonizing? Quantum immortality does not promise the preservation of quality, dignity, or identity. It simply ensures the persistence of experience. You may remain alive in branches where your body is severely damaged, where cognitive function declines, where pain becomes chronic, where isolation deepens. Consciousness might cling to whatever minimal configuration still allows awareness. Some thinkers have even argued that the most terrifying implication of quantum immortality is not living forever, but living through states you would never choose if you had any control over the branching. A kind of endless survival that outpaces meaning, a twilight of awareness stretched across improbable timelines. A cursed immortality born not of strength, but of the impossibility of perceiving non-existence. This possibility forces a blunt question. Is immortality desirable if it does not guarantee joy, health, or coherence? Would you want to outlive every version of yourself except the one trapped in the thinnest corridor of possibility? And if consciousness truly flows in this direction, what responsibilities do we carry in the only branch we can feel, the one we are experiencing right now? The idea unsettles because it flips our intuition about luck. We think of survival as fortunate, as a blessing, as the universe giving us another chance. But through the lens of quantum immortality, survival may simply be the default path, not because it is good, but because it is the only path awareness can follow. The question becomes not why did I survive, but what does it mean that I always do? If this thought resonates with you, if the idea of a survival path narrowing through infinite branches makes you reflect on the shape of your own life, take a moment to ground this realization. And if you feel compelled, show me you're still here by liking this and writing in the comments. I remain in the unlikely branch. For all its unsettling elegance, quantum immortality begins to unravel the moment you examine its assumptions with scientific discipline. The idea feels powerful because it sits at the intersection of subjective experience and quantum possibility, but that same intersection also exposes its weak points. The first and most fundamental criticism comes from Max Tegmark himself, the physicist whose thought experiments popularized the concept. Tegmark has repeatedly emphasized that quantum immortality is not a prediction of physics, but an extrapolation of personal identity, one that may rest on faulty logic. The main issue lies in the treatment of probability. In quantum mechanics, not all branches of the multiverse are equal. Some have high amplitude, meaning they are far more weighty in the overall structure of the wave function. Others are vanishingly small, so improbable that they contribute almost nothing to the collective behavior of the universe. Quantum immortality treats these rare branches as just as valid as the common ones, as if a billion-to-one pathway of survival carries the same experiential relevance as the path everyone else sees. Critics point out that ignoring amplitude is equivalent to throwing out the very mechanism that gives quantum theory its predictive power. Sean Carroll offers a different angle of criticism. The argument depends heavily on the idea that consciousness follows a single line through the multiverse, but many worlds does not actually define or privilege a particular line of experience. It describes the evolution of the wave function, not the trajectory of a mind embedded within it. According to Carroll, we have no scientific theory of consciousness that links awareness to a specific quantum branch. Without such a theory, any claim about where consciousness goes becomes speculation. The structure of the multiverse may allow every outcome, but nothing in physics dictates how subjective experience navigates those outcomes. Another challenge comes from philosophers like David Papineau and David Deutsch, both sympathetic to many worlds, but skeptical of immortality claims. They argue that survival in one branch does not constitute continuity in any meaningful sense. You do not jump from one branch to another. The branches evolve independently. The version of you who dies in a particular branch does not get rescued by a parallel version. That person is simply gone. The surviving copy is not an escape route, but an entirely separate individual, even if they share your memories up to the point of divergence. From this perspective, quantum immortality confuses psychological continuity with physical identity. There is also the problem of anthropic reasoning. The fact that you are alive to observe your own survival does not imply that you survive in every possible scenario. It only implies that observers will always find themselves in branches where observers exist. This is tautologically true, but tells us nothing about what happens in branches where consciousness ends. Just because you never observe your own death does not mean you survive it. Rather, the branch where you die simply contains no you left to observe anything. Critics warn that the entire concept might be built on a linguistic illusion, mistaking the persistence of experience for the persistence of the experiencer. Quantum mechanics is silent on meaning, purpose, identity, or the continuity of the self. It does not guarantee that awareness flows into certain branches or avoids others. It only describes what physically happens, not what it feels like to be someone inside the system. In the end, the failures of the argument do not make quantum immortality impossible. They simply make it unproven, fragile, and deeply dependent on assumptions we cannot yet justify. The theory remains a haunting possibility, but one that stands on uncertain ground. If quantum immortality raises scientific questions, it raises even deeper philosophical ones, none more unsettling than the problem of identity. What exactly is the you that supposedly persists through the unlikely branches of the multiverse? Are you a single continuous stream or merely a pattern that reappears moment after moment? These questions form the core of the argument's most fragile point. Continuity of consciousness is not guaranteed simply because memories line up in a familiar order. To approach this, imagine the self not as an unbroken line, but as a sequence of frames in a film reel. Each frame is static, yet when played quickly it creates the illusion of motion. Some philosophers argue consciousness may operate in a similar way, forming the sense of flow not from an actual continuity, but from the memory each moment carries of the one before it. If this is true, then the line of consciousness may be less of a line and more of a reconstruction, something assembled on the fly. It would mean that identity is not a river, but a story the brain tells itself to make sense of experience. In this context, the many worlds interpretation becomes even more complicated. If every branch contains a version of you with identical memories up to the moment of divergence, then which one is the real continuation? All of them? None of them? The notion of a single privileged self sliding through the branches begins to collapse. Each version believes it is the original, and each experiences its own world as the authentic one. The subjectively felt continuity exists in all of them, yet each is separate and unaware of the others. This is where quantum immortality meets its deepest contradiction. The idea of a unique you surviving in a rare branch assumes there is only one meaningful thread of identity. Sean Carroll emphasizes this point sharply. A continuation of memories does not necessarily imply the continuation of the self. It only implies that someone, somewhere in the multiverse, remembers your life and feels like you. But identity, in the strictest sense, is not guaranteed by resemblance. A near-perfect copy is still a copy, and if consciousness is emergent rather than fundamental, then what you call you may be nothing more than a highly intricate pattern instantiated in matter. Patterns do not hop branches. They simply occur wherever physical conditions allow them to occur. This becomes clearer when we bring in a classic scenario, teleportation, the kind imagined in Star Trek. If your body is disassembled atom by atom and rebuilt elsewhere with identical structure and memories, is that person still you? Many philosophers argue no. The consciousness that awakens in the new location is a perfect duplicate, but the original has been destroyed. There is no transfer, only replication. And if that logic holds, then survival in another branch of the multiverse does not rescue the version that dies in this one. It merely means a different version continues with the illusion of seamless identity. Carroll once described the shooting example starkly. If someone kills you from behind in this branch, the fact that a version of you lives in another does nothing for the person who dies here. That person's story ends. The continuation elsewhere is irrelevant to the individual who no longer exists in this world. The philosophical challenge, then, is not whether alternate versions of you survive. It is whether any of them can meaningfully be called you at all. Identity may not be a line that stretches across worlds. It may be a local phenomenon tied to a single physical trajectory. If that is true, then quantum immortality does not offer survival. It offers replacement. And whether that comforts or terrifies depends entirely on how you define the self. The mathematical heart of quantum mechanics presents a far colder picture than the seductive narrative of quantum immortality suggests. When physicists talk about branches of the wave function, they do not mean parallel worlds of equal weight drifting apart like pages from a storybook. The wave function is governed by amplitudes, and those amplitudes determine the probability of each outcome. In this framework, not all branches are created equal. Some dominate, carrying almost the entirety of the probability mass, while others shrink into negligibility. Quantum immortality often ignores this structure, treating every possible survival branch as equally valid simply because it exists. This is where the first major mathematical objection arises. If the amplitude of a survival branch becomes extremely small, so small that its contribution to the wave function is effectively zero, can it still be considered part of your subjective future? The many worlds interpretation does not discard tiny branches, but it also does not grant them equal experiential relevance. They are mathematically real, but vanishingly insignificant. Critics argue that building a theory of personal survival on these branches is like building a life raft out of shadows. The structure is present only in the loosest, most abstract sense. Furthermore, quantum mechanics is a linear theory. The wave function evolves smoothly according to the Schrödinger equation. There is no mechanism in the mathematics that reweights reality in favor of the observer's survival. Branches where you die do not dissolve or disappear once consciousness ends. They continue evolving with their full amplitude. The mathematics does not care about the fate of any observer inside the system. It only describes the evolution of states. From this perspective, the notion that your awareness slides into survival branches is a human projection, not a physical rule. Another core issue involves the misinterpretation of probability. In many worlds, probability is not about which outcome happens, since all outcomes happen. Instead, it is about how much of the wave function structure supports each outcome. A survival branch with tiny amplitude is like an extremely faint signal buried in overwhelming noise. Quantum immortality would require that consciousness is drawn toward these faint signals regardless of amplitude, which contradicts the standard mathematical interpretation used by nearly all physicists. There is no known principle in the formalism that grants consciousness the ability to navigate probability space in this selective way. The argument becomes even weaker when considering decoherence. As the universe branches, decoherence rapidly isolates outcomes from one another, creating distinct worlds. But decoherence does not prune branches. It does not favor clean pathways of survival. The mathematics simply lets all outcomes spread out, each with weight determined by amplitude. If you were to follow the mathematics strictly, the overwhelming majority of your future selves, across all branches, die when probability suggests they should. The tiny handful that survive improbable events are mathematically dwarfed by the versions that do not. To build a theory of personal continuity on these rare branches is to ignore the statistical architecture of the wave function itself. This leads to the key point. Quantum immortality is not a mathematical consequence of many worlds. It is a philosophical overlay placed on top of the equations, one that requires consciousness to behave in ways the formalism does not justify. Physics describes what happens in the universe. It does not define the path of subjective experience. Without a theory of consciousness that can bridge these two domains, the assumption that you will always find yourself in a survival branch remains unsupported. The mathematical refutation does not eliminate quantum immortality entirely, but it weakens its foundation. It shows that the idea rests not on the equations of quantum mechanics, but on a speculative interpretation of what it feels like to be alive inside one of its countless branches. At the base of quantum immortality lies a question neither physics nor philosophy has been able to answer. What is consciousness, and how does it relate to the physical world? Every argument for or against survival through quantum branching eventually hits this wall. Without understanding what awareness fundamentally is, we cannot say how it would behave in a multiverse, or whether it could even be said to follow anything at all. In classical physics, consciousness is treated as irrelevant. The universe unfolds according to laws that do not care whether something is observed or not. Yet quantum mechanics complicates this simplicity by linking measurement to the emergence of definite outcomes. It becomes tempting to imagine that consciousness plays a special role, that the mind is somehow tied to the branching structure of the wave function. But this temptation reveals more about human intuition than about the physics itself. Brian Greene has pointed out that quantum theory does not define observers as conscious beings. Measuring devices, atoms, even interactions between particles can act as observers in the technical sense. The collapse or branching of states has nothing to do with awareness. It is a physical process indifferent to the presence of a mind. If this is correct, then consciousness is not steering the branching of reality, nor selecting survival paths. It is simply riding along, a byproduct of whatever physical configuration happens to host it. Lev Vaidman, a defender of many worlds, argues that consciousness is spread across branches, but not privileged within them. In his view, there is no singular stream of awareness weaving through the multiverse. Instead, each branch contains its own version of conscious experience, none more authentic than the others. The idea of a unique you persisting through unlikely branches becomes incoherent under this interpretation. There are only many, each unaware of the others, each believing itself continuous. The question becomes even more complex when we consider theories that treat consciousness as emergent rather than fundamental. If awareness arises from neural activity, and if neural activity is entirely physical, then each branch of the multiverse contains its own emergent consciousness tied to that specific brain. No soul jumps between worlds. No hidden pattern selects a path. The continuity you feel is generated locally, within the physical structure of your brain, not across the branching architecture of the universe. This perspective undermines the core intuition behind quantum immortality. The argument relies on the assumption that there is a single line of consciousness that must continue wherever possible. But if consciousness is nothing more than information instantiated in matter, then each branch simply contains its own separate instance of that information. The version that dies in one branch does not hand off experience to the version that survives in another. The one who dies is gone. The one who lives had always been living in that branch. They share a history, but they do not share a self. This leads to the most profound and unsettling question of all: who exactly is the you that never dies? If consciousness is branch-bound, then no singular identity continues indefinitely. If it is something deeper than physics, we have no scientific framework to describe how it might navigate the multiverse. And if it is an illusion, a story the mind tells itself, then quantum immortality becomes not a cosmic truth, but a misunderstanding of what it means to be aware. The concept remains compelling because it amplifies a mystery we cannot avoid. Consciousness is the one phenomenon we experience directly, yet the one we understand the least. Without resolving what awareness truly is, the question of immortality in a quantum universe remains suspended, floating between speculation and metaphysics, as unfinished as the wave function itself. In October of 1962, the world came closer to ending than most people realize. The Cuban Missile Crisis is often remembered as a tense standoff, a diplomatic chess match between superpowers. But beneath the official narratives, there was a moment so narrow, so fragile, that our continued existence can be traced to the decision of a single man in the belly of a Soviet submarine. The submarine was named B-59, and it was trapped beneath the surface near the American blockade line. The crew had been cut off from communication for days. Temperatures on board reached unbearable levels. Carbon dioxide climbed to dangerous concentrations. The sailors were exhausted, dehydrated, disoriented, and convinced that war had already begun. Above them, US Navy ships dropped practice depth charges meant to force the submarine to surface. To the men inside, they sounded like the opening salvos of nuclear conflict. The B-59 carried a weapon of its own, a T-5 nuclear torpedo powerful enough to ignite the war everyone feared. The protocol was simple and horrifying. 3 officers had to agree to launch. 2 of them did. Only one refused. His name was Vasily Arkhipov. He was not the commander of the vessel. He was the second in command. And yet, by insisting that the crew surface instead of firing, he prevented a nuclear chain reaction that would almost certainly have escalated into the destruction of major cities, the collapse of global infrastructure, and the death of millions. It is not an exaggeration to say the world stood on the edge of oblivion. Had he chosen differently, you would not be reading this. Your parents might never have met. Entire lines of ancestry would have ended before they began. Humanity would have split into 2 branches of history, one where civilization continued despite the terror, and one where everything was reduced to ash. This historical moment, when viewed through the lens of quantum theory, gains an eerie resonance. If the universe branches with every decision and every random fluctuation, then there are versions of reality in which Arkhipov agreed to launch. In those worlds, the war began in minutes. Cities vanished. The Cold War became a brief and catastrophic event rather than a decades-long standoff. Civilization in those branches ended in 1962. And yet, from your perspective, you inhabit the branch where the torpedo never left the submarine. You exist in the version of reality where a single man's act of restraint prevented the collapse of everything you know. The other branches, if they exist, contain no observers capable of telling the story. In those worlds, no one survived long enough to argue about interpretations of quantum theory or contemplate the nature of consciousness. Only silence remains. The power of this incident is not that it confirms the multiverse. It is that it exposes how precarious our existence has always been. History is full of razor-thin moments where everything could have ended but didn't, where some improbable alignment of caution, intuition, or sheer luck allowed the thread of human awareness to continue. In the context of quantum immortality, the story becomes even more haunting. If consciousness persists only in branches where survival remains possible, then you are, in a sense, living inside one of the rarest and luckiest paths history has ever taken. The world almost disappeared, but you are here, and that fact alone forces us to confront the strange and fragile nature of the reality we inhabit. quantum mechanics leaves us standing before a universe stranger than anything intuition can hold. Many worlds is unproven, yet impossible to dismiss. Quantum immortality remains a disturbing shadow born from its logic. Still, one truth lingers. Consciousness continues observing, shaping meaning from uncertainty. And the fact that you are here, aware in this branch, is extraordinary on its own. If this journey through quantum consciousness sparked something in you, like the video, and join the community exploring these deeper questions. Subscribe if you want more explorations into reality, observation, and the hidden structure of existence. And if you made it all the way here, write in the comments, "I am still aware."